Hi everyone, today I'm going to introduce our recent work on Multiwoz dataset. In this work, we improve this dataset in two aspects, the annotation inconsistency and entity bias. And our presentation will follow the order of background and these two aspects of improvement. Multiwoz is one of the most popular task-oriented dialogues dataset. Introduced by Power in 2018, it contains more than 10,000 dialogues across multiple domains, and each dialogue is well annotated with dialogue X dialogue slots. Therefore, many dialogue models and frameworks for various dialogue tasks like dialogue state tracking, response generation, dialogue policy management, and even end-to-end dialogue are evaluated based on that. As attracting more and more attention, the dataset get improved by many works. In 2019, Eric modified around 40% terms, in other words, 30% dialogues, to correct some semantic annotation errors and typos. They also add slot description for exploring future learning. Based on the version 2.1, Zhouhan and her team proposed the Multiwoz 2.2 in 2020 by further correcting the annotation errors, including both dialogue slots and dialogue actions. Our work is basically based on the version 2.2. Different from the first two versions, which focused on whether the annotation does make sense based on the single related dialogue, which we can call a dialogue level. We care more about the pattern in the whole dataset level. In other words, we care whether the pattern of a slot annotation are consistent among the whole dataset. This is because we wish the model to learn the pattern of annotation. However, if the pattern is always changing, that will probably confuse the model. And as I mentioned before, this dataset attracts more and more attention, and more researchers are willing to help improve this dataset. So another two work, version 2.3 by Han and 2.4 by Ye, has been published so far. So for the first aspect, the annotation inconsistency, we found that there are many cases that two dialogues have very similar context and user audiences, but the slot annotation strategy can be quite different. For example, in this case, in both two dialogues, the user is asking for a tourist attraction that should be in the central area of city, which is included in the previous turn and not in this part, and should be the type of architecture. The contexts are quite similar, and the annotation at this turn are exactly the same, just the area center and the type architecture. Continuously, the assistant offers the same result, all things church, and the user shows interest in this church and continuously asks for the entrance fee in both dialogues. However, the annotation at this turn are quite different. The first dialogue still only contains the area and attraction type, while the second dialogue includes the attraction name, All Saints Church. This really confused the model whether it should generate the slot of attraction name or not in such a similar cases for the dialogue state tracking task. And during the test, you can see the model decided to generate the attraction name in this case. However, the ground truth does not include that. So based on the definition of the joint goal accuracy, which is the matrix of the joint dialogue state tracking task, the prediction of this turn is wrong, but actually the model performs not bad from my point of view. And after statistical analysis, we found that most of such missed or inconsistent annotation lies in the slot type name, or type. As it happens, when we run simple chat, one of the state-of-art dialogue state tracking model, or an end-to-end dialogue model, when we run simple chat on Multiwoz and count the numbers of turns that with prediction errors, the slot type with the most error turns are exactly name and type. Therefore, we decide to complete all missed annotations. So we go over all the dialogues in the test set and write some regular expressions to add the missed annotation. Totally, there are like 70% dialogues and 50% turns involved in the modification. We also apply the regular expression to the training and the validation data, and also around like 70% dialogues involved. We then, to check if the regular expression really fit the training and validation data, we randomly sample 200 dialogues from the training data, 100 modified data, and 100 unmodified dialogue. And we manually check whether the regular expression can successfully modify these dialogues. The result shows that around like 97% of the dialogues are correctly changed. We then run some experiments with three typical dialogue state tracking model: tray, simple chat, and fine-tuned BART model. We test the three different versions of Multiwoz: 2.1, 2.2, and ours. The result shows that the joint goal accuracy on our test set is higher than other two by like 10%, which means the model actually performed quite good in those 10% turns. We also count the fuzzy match result, since there can be many different names for one single object, like A and B guest house, the A and B guest house, A and B hotel. All of them are referred to the A and B hotel. So we use fuzzy match to count the model's prediction as true if it is quite similar with the ground truth. No need to be exactly the same. The result then increased for like 5% for the best model on our test set. We again count the number of turns that the model make mistakes for each slot type. The light red one means the number of error turns test on the Multiwoz 2.2, and the dark blue one is the test on our test set. We can find that the number of error turns for the slot type name and type decreases a lot after modifying the data. This again verifies that missed annotation lies mostly in these slot types. One interesting thing is we count whether the newly added slots are extracted from user utterance, like the dark blue bar here, or the system responses marked with the light red in the graph. And you can find that the light red one takes the most part. So this means the most newly added slots comes from the system side. What does this mean? This means the annotators who annotate those slots, they agree to annotate the slots in the user utterance, but for those information from the system side, they are not sure whether to annotate or not. So this is the reason for the strategy inconsistency. As for the ended bias part, we found an interesting phenomenon by analyzing the generated result by simple thought model. Like in this case, the model generated the slot train destination Cambridge, while the token Cambridge never shows up in the dialogue context. We then hypothesize that the model learns this token in the training data. Then we count the number of frequency of each slot value for the slot type train destination. And the result here shows that the value Cambridge shows much more frequently than others. Similar cases show up in other slot types. These added bias are potentially amplified by the learning model, which would lead to bias generation. But different from the annotation inconsistency problem, we do not make any modification to the training data with respect to the added bias. Strictly speaking, bias cannot be considered as a source of error in the dataset, and it needs to be tackled via better modeling efforts. Therefore, we only modify the test set in order to check if the model really understands the input utterance and extract the slots, or just generate based on the statistics. Specifically, we replace all slot value with new unseen entities from the Google FGD dataset to form a new test set. We then run model on the new test set and compare with the old one. There's a huge drop, like 29% in the joint-code accuracy. And from the cases here, where after replacing the entities, the model still prefer to generate the values that frequently show up in the training set, like the Cambridge, the London King Cross. And based on that, we can see that the model generates depending more on the statistical memory rather than the input utterance. And we should definitely care about this point when modeling dialogue systems. So in conclusion, we propose to improve Multiwoz in two directions: annotation inconsistency and added bias. For the annotation inconsistency, we manually modify the test set and automatically modify the training and data set. And for the added bias, we also introduced a new test set with unseen entities. We hope the modified Multiwoz can help the community much further for building task-oriented dialogue system. And that will be all for today's presentation. Thank you so much for your time and attention.